Okay, hello everybody. Welcome. If you can hear me, please put your name in the chat. Okay. I see Ruda there. Right. Last time, how did the test go? We had started to talk about the first four topics. We had summarized the first four topics of the. Okay, not too bad. Okay. Should we go through questions from the first three topics that we talked about last time? Should I summarize and we go through questions, or should we move on? I don't understand, Ruda. What is the yes please for? What is the yes please for, Ruda? Are you saying we move on to the next thing, or you're saying we summarize and we do questions? All right, so the first three questions, we summarize and we do questions. Okay. The first three topics. Now, we do know that our pure mathematics 3 has 9 topics, right? Our pure mathematics 3 has 9 topics. Now, we know that the first topic is algebra. Then we have exponents and logs. Then we have trig. So this is what I meant by saying the first three topics. We have these things, and last time we kind of talked about them real quick because you are preparing for a test, Ruda. So today we're gonna go through them again. Is it only you in the lesson? If you're in the lesson, just tell me by telling me the names. I want to know the names of everybody who's in the lesson. All right. So in algebra and functions, the main things I can say that the main things that people need to understand in this topic of algebra, the first one, is if we're summarizing the things that. Oh, hi Grace, how are you, Nyasha? I see Nyasha is there. All right. So here are the things in algebra. The very first thing you should be able to do polynomial division. Okay. Let me just quickly put the things, then we go through them fast. So every day, if we just do questions, you'll be fine. Trust me. Polynomial division. Then you have remainder theorem. And then you're going to have factor theorem. Okay. Then you're going to have partial fractions. Which always comes. Then you're going to have binomial expansion. I want you to put the main things from topic 1, okay? And I'm going to be covering the things daily. We just do the things and we move on real quick. I'll try to be as quick as I can. Okay, I'll show you how you solve modulus equations, how you sketch them and stuff. Then here we will do the polynomial division, remainder theorem. Did I write modulus? I didn't. Okay, let me write it. Modulus functions. Modulus functions. It's part of algebra. You should be able to solve them. You should be able to sketch them. Okay? Generally, if you know these things, we can say you have done this topic. So, right, I'm going to start with the things that I can tell you in a few minutes and you do. Then we go, so it's back to front. It's kind of like a back to front approach. When we are done with this, we'll go to the second topic as quick as we can, do questions. Then we'll go to the third topic as quick as we can and do questions. So we should make sure we do even 20 minutes every day is fine. Just to make sure you get momentum, you get red hot, and I can push with the other subjects as well. So this should be there for every single subject, okay? So if we can do just 20 minutes, 20 minutes, 20 minutes of everything, that's an hour a day. That's great. Right. So let's quickly talk about the things that people have to know. So I'm going to be going to, I'll just say one or two things, then I go to past papers and I'm going to focus on that. That is where I'm going to mostly put my focus on. So if we start with what? I'm going to start with the polynomial division thing. And then from there I can go to the next thing, to the next thing. There are a lot of things. Let me just say the other thing is about factorizing cubic equations or expressions. We'll talk about it. But it will be kind of related to the first things that I've said. Okay. So if it's a bit of repetition, it doesn't matter. You'll be fine. We're starting with topic 1, algebra, because you said I should just do a quick rerun for the next few days through every single thing and catch up real quick with your lecturer, with your teachers. So I'll be moving very fast. Right. Polynomial division. I'll be moving fast. So write this. So when you do polynomial division, you follow this order. If you're doing polynomial division, this is what you do. Divide, expand, subtract. Full stop. So if they say, do this one, look, these are the things. Divide, expand, subtract. This is the order that we do for everything that we do. It's divide, expand, subtract, divide, expand, subtract, divide, expand, subtract, divide, expand, subtract, divide, expand, subtract. So whatever question they're going to give us, this is the order we're going to do, okay? You're going to divide. What do you divide by? The first term. Then you're going to expand back. The answer, you multiply by everything, you subtract. You keep doing this. This is polynomial division. And everything I want to do past paper questions, but I'm just going to do one question to make you know what I'm talking about. Then we go to past paper questions, past paper, past paper, past paper. Here's the one question that you should do. Here is the one question, which is a past paper style question. It says, for the polynomial example question. What did I say about polynomial division? DES. If you change it, you're in trouble with me. Here it says, and we go to the next thing. For the polynomial, f of x is equal to x cubed plus 6x squared minus 9x minus 14. This is what we have. Part A. Divide f of x by x plus 7. Part B. Find the remainder. So after this, we'll end up talking about the remainder theorem. Find the remainder when f of x is divided by x plus 3. So make sure that whatever you're doing, you're thinking, you just make your thinking stick to what we are doing right now. Don't think about anything else. Just do what we are doing. We'll go on to the next. Don't worry about everything else. Everything else will have its place. Don't worry about it. Focus on what we are doing right now. For the polynomial, f of x is equal to this. Divide by x minus. So polynomial division, you'll be saying x plus, we are doing solutions now. So you're saying x plus 7 is going into x cubed plus 6x squared minus 9x minus 14. Guys, these are the parts of algebra. If you know polynomial division, remainder theorem, factor theorem, partial fractions, binomial expansion, this and this, you are done with the chapter 1. Then you go to the next thing. That is what the chapter is. So polynomial division, you don't do your own thing. Remember, I said it's DES. Divide, expand, subtract. You follow those steps till you get to the end. So when you divide, you only divide by the first term only. So first term only. Okay, this D is divide, this E is expand, this S is subtract. So divide, expand, subtract. Let's do the division. Okay, when you divide, I want you to know that it is term by term. It is at a term by term basis. So we'll be now saying x goes into x cubed. What do you get? X into x cubed, you get x squared. So you have divided. What should you do? Don't divide again. Expand now. You take x squared. It should multiply this whole thing. So with a pencil, x squared multiplies x plus 7. You are expanding now. X squared times x, it becomes x cubed. X squared times 7, it becomes plus 7x. Then this whole answer that you get, you subtract it. The whole answer, so you say minus now, in brackets you say x cubed plus 7x inside a bracket. Then now you're going to say x cubed minus x cubed, they cancel out each other. 6x squared, there is no x squared in the bracket. Oh, this is supposed to be 7x squared. By the way, that's a mistake there. Because there's an x squared by 7, it becomes 7x squared. So there's an 6x squared minus 7x squared. 6, remember to put the minus out of the bracket. 6 minus 7, you're punching the calculator. You get minus 1 of what? Of x squared. You get minus of x squared. Then there's nothing with an x, so the minus 9x just comes down. There's nothing with another number, so the minus 14 just comes down. Now you say x again. You've subtracted, right? You've divided, you've expanded, you've subtracted. What do? You divide again. Right? Now we are dividing. Remember, we are dividing by x plus 3. Let me reduce the thickness. This is way too thick. All right, so it's going to be now. We are dividing by what? X plus 7 rather. So we divide again now. X now goes into negative x squared. Okay? What do you get? You get negative, because the signs are different. When you divide two different signs, you get negative. Then x into x squared, you just get an x. Then what do? You expand. You take the answer you got from dividing this one, you expand it with this whole thing. Don't change. That's the steps. They are never to be broken. So it's minus x multiplying x plus 7. This becomes minus x times x. It's minus. The signs are different. X times x, x squared. Minus x times 7, it's minus. X times 7 is 7x. So it's minus x squared minus 7x. You take that answer, you are subtracting it. Minus x squared minus 7x. Now what do? You say minus x squared minus minus. It's like minus x squared plus x squared. It cancels, becomes nothing. Then you now say minus 9x minus a minus 7x. So it's like you're saying minus, it's like plus. Minus 9x minus minus becomes plus 7x. So you say minus 9 plus 7, you get minus 2. Of what? Of x. Is there anything with the number? No. So the constant negative 14 comes down. It follows. And you will now say x into negative 2x. You will get negative 2, because x, negative 2x divided by x. The answer is negative because the signs are different. One is negative, one is positive. So the answer is negative. X and x cancels, you just get a negative 2 like that. Anyway, so that'll be the answer, -2. What do? You have divided, expand. So -2, the answer should multiplying x plus 7. -2 times x, you get -2x. -2 times +7, the answers are different, it's negative. 2 times 7, that's 14. So it's -2x minus 14. So this is going to be your solution. And you are subtracting it. So you're going to say minus of -2x minus 14. So you have something being subtracted by itself. You can see that inside the bracket and outside is the same. So it's canceling itself. You are going to get nada, which is 0. So what is going to be the solution? You basically can say, what is what? What was it? X cubed plus 6x squared minus 9x minus 40. Divided by x plus 7 will give you this answer. To just give you x squared minus x minus 2. This is going to be your final solution. Anyone with a question? Rodawiro, have you seen? So it is divide, expand, subtract. If you use this, nothing will ever catch you. Once you see the word divide, polynomial, just use DES. You will be fine forever. Don't change. Use DES. Divide, expand, subtract. Divide, expand, subtract. Divide, expand. Now, we'll go to the part B, which is remainder theorem. So it's like they move together, okay? Polynomial division, remainder theorem, and factor theorem move together. So we are doing these two first. Don't worry, you add stone by stone. You don't just jump, okay? Let's do remainder theorem as the last thing. Factor theorem, I do polynomial division and remainder theorem, and I'll be happy. What does the remainder theorem say? It's a theorem. It says something, okay? It says, if f of x is divided by x plus a, the remainder will be f of negative a. So it says change the sign here, then you will have the remainder. So what is the remainder? Change the sign and put it back into the function. Then you will get the remainder. You actually calculate f of negative a. You will need to put it back into here. Don't see, f of negative a is actually a calculation. So you will change the sign here, then go and feed back into the original thing. Okay, change and feed back into the original thing. Then what the answer you get is going to be the remainder. It's as simple as that. So let's see what they said here. They said find the remainder when f of x is divided by x plus 3. So let's put our f of x first. Here our f of x is going to be equal to x cubed plus 6x squared minus 9x minus 14. And it is being divided by x plus 3. So remainder, okay? If you can say if this is divided by x plus 3, remainder is equal to f of negative 3. Just change the sign here. Period. Remember, remainder is f of negative. That will never change. That's the remainder theorem, full stop. So you're going to say f of negative 3 is going to be equal to negative 3 all cubed plus 6 by negative 3 all squared minus 9 by negative 3. If you want, you can even rewrite it so that there is nice sequence. F of x is equal to x cubed plus 6x squared minus 9x minus 14. Then you can say let x equal to negative 3. You now say f of negative 3. F of negative 3 is equal to negative, where there is x, wherever there is x, we are now putting negative 3. So it will be cubed plus 6 by negative 3 squared minus 9 by negative 3 minus 14. This is going to be negative 27. Okay, then negative 3 by, that's 9, so it will be plus 6 by 9. Then minus 9 by minus 3, that's plus 27. That's minus 14 now, which becomes negative 27, and positive 27 will cancel. Then here you get 54 minus 14, you get 40. So here, if I made a mistake, please tell me in the chat. Remainder is 40. This is going to be the remainder. Does anyone have a question? Is there anyone with a question? Okay, good. I'm happy. This is what the remainder theorem says. Maybe just to give you one thing to go with. I'm thinking, should I give you the factor theorem or should I not? It's the last one. I won't do a question on it. Okay? I will not do a question on it. Okay, we'll do factor theorem tomorrow. Let me not put you under pressure. No, it's fine. Just do remainder theorem and polynomial division. Should I do factor theorem? Should I mention it? Should I mention it? Should I just make you write it? Or we'll do it tomorrow? Okay, I'll make you write it. Factor theorem says, if f of x is divided, or let's say if f of x divided by x plus a gives a remainder of 0. Or let me say, this is the easiest way. If f of negative a is equal to 0, then x plus a is a factor. This is the easiest way to say it. And if you want to say it again below, if f of negative b is equal to 0, then, or let's say f of b is equal to 0, then x minus b is a factor. Basically, we are reversing it. What we are doing is we are saying, remember for remainder, oh guys, do not let me down. Remember, for remainder, you feed a value into the function. When you feed a value into the function, you are looking for a remainder. To get remainder, when we divide by x plus 3, we feed minus 3 into the function. So when you see yourself feeding a value into the function, you are looking for the remainder. Look, here, what did we do? We fed minus a. So what were we looking for? The remainder. And what remainder did we get? The answer became 0. So that means the remainder is 0. That means that this guy will be a factor. Anything which gives you remainder of 0 will be a factor. And we know how it gives you remainder of 0. We know how to get remainder. We'll feed the opposite of here. We'll feed into the function. We were looking for remainder. Here we got remainder of 0. So that means this guy is a factor. He gives remainder of 0. So he is a factor. F of b, we are feeding b. So we are looking for the remainder when we divide by x minus b. We are looking for remainder when we divide by x minus b. And because we are feeding b, and here we got an answer of 0, which means we are getting a remainder of 0. If you get a remainder of 0, that means that x minus b of yours is a factor. So what we will do, they will tell us, most of the time, they will tell us that something is a factor. Okay? They are going to tell you that something is a factor. When they tell you that something is a factor, you are going to apply the theorem. And when you apply the theorem, you will be able to find whatever the values. They will reverse it. I'll call you back. I'll call you back just now. Okay, TS. I'll call you back just now. So you'll be finding, you'll find the remainder, whatever the situations, okay? So if you get remainder 0, it's a factor. The guy who is dividing, whoever, because we will be looking for remainder if we feed here. And here is the remainder. So if the remainder is 0, that means whatever you're dealing with is a factor. Goodbye. We are going to meet again tomorrow, and we'll continue with these ideas. Keep them somewhere safe. Factor theorem will never change. Remainder theorem will never change. It says if you are dividing by x plus a, the remainder is f of negative a. So factor theorem is actually a friend of remainder. It's a part of remainder theorem. For factor theorem, we will be now getting remainder 0. We'll be trying the remainder theorem and we get a remainder 0. So we say, why? That means it's a factor. Okay. Thank you so much for attending. We meet again tomorrow.